Question 41, Electrical Engineering, GATE 2017 Set 1. The switch in the figure below is closed for a long time. It is opened at t equal to 0. The current in the inductor of 2 Henry for t greater than 0 is dash. 4 options are given to us. For a detailed lecture on the basic concept, please refer to the NPTEL video First Order RL Circuits by Dr. Nagendra Krishnapura, Department of Electrical Engineering, IIT Madras. We need to know the basic concept on RL transients in order to solve this problem. Consider this network where we have a resistor in series with the inductor, and this is connected to a voltage source. Let's say the switch is thrown at time t equal to 0. The instantaneous current through this inductor is given by the final current or IL infinity plus the transient current. Transient current is the current that is flowing between the instant 0 minus and the final instant or IL infinity times e to the power minus t divided by tau. So this is the value of the instantaneous current I of t. The value of tau is the time constant, which is given by the value of the inductance divided by the resistance. Let's make use of these two formula in order to solve this problem. In the problem, it is given that the switch is opened at t equals 0. So before that, the switch remains closed. So at t equals 0, the switch is opened and it is source free. So the network will become like this. Since the switch was closed for the long time, the 50 volt power source will have powered this network and the inductor will be charging. So after it is charged, it can be replaced as a short circuit. So this is the short circuit of the inductor. Let us denote this as IL 0 plus. IL of t is given by the current up to which the inductor is charged times e to the power minus t divided by tau, where tau is the time constant of the network. Time constant is equal to L divided by R. Since we have a network of resistors, it is L divided by the effective resistance. So now let's find out the value of effective resistance looking at the perspective of this inductor. The effective resistance is given by 32 ohm in parallel with 32 ohm in parallel with 8 ohm plus 8 ohm. This will be 16 ohm parallel with 16 ohm, which is 8 ohm. Therefore, the time constant is given by 2 Henry divided by 8 ohm, which is 1 by 4 second. We have now found out the value of time constant. Now let's find out the current up to which the inductor got charged. At t equal to 0, this network becomes a source free network. Before that, we have a source of 50 volt. So we have a 50 volt connected in series with 6 ohm resistor, and the switch is closed before t equal to 0. And we have this network at the right side. Let's concise this. 32 parallel with 32 will be 16 ohm. Let's replace this parallel combination as 16 ohm right away. So at t less than 0, the inductor will again be fully charged. So we can right away replace this as a short circuit and find out the current through this short, which is IL 0 minus. In order to find out the current supplied before the switch is opened, we need to find out the total current supplied by the 50 volt source. Let us denote it as IT. IT will be 50 volt divided by the effective resistance, which is equal to 50 divided by 6 plus 8 parallel with 8, which is equal to 50 divided by 10, 5 ampere. So 5 ampere is the total current that is flowing into this network. This 5 ampere divides into 2 into this 8 ohm and 8 ohm. Because of the shorted path, this current straight away goes into the short, leaving the 16 ohm resistor. Combining with this current, this 5 ampere goes back. Therefore, IL 0 minus will be the current through this branch, which is the current through 8 ohm resistor. So by current division rule, it is the total current times the other resistor divided by the sum of two resistors. So the 5 ampere will be halved and the current that is passing through this is 2.5 ampere. IL0 minus is 2.5 ampere. Now we have got the values of IL0 minus as well as the time constant. Let's substitute them over here in order to find out the current equation. This is equal to 2.5 e to the power minus 4t ampere, which is nothing but option A. Option A is the correct answer. Thank you.